All right, so let's continue on. We're gonna start solving logarithmic functions. So we're gonna start solving logs first, and then we're gonna go and we'll solve exponentials. We did a little bit of this back at the first part when we were evaluating. Remember, the two words you need to look for are evaluate and solve. That's when you're gonna know when to solve. All right. So your learning target is that you can solve log equations. All right. So we are on page 11. All right, at the bottom, a logarithmic equation can be solved using the properties of logs, expanding and condensing. So that's why we did the expanding and condensing first. And if you look, I have the charts on your paper, and it just reminds you of how to expand and then what those rules are. So when you're multiplying, you add. Whenever you divide, you subtract. And whenever you have a power, then it goes out front. Okay? So that's something that you needed to remember. It's the same thing with the LN, which is a natural log. The only difference is you don't put log base E, you just put a log, or you put LN, sorry. Now, remember, when there's not a base there, it's a log of 10. But you don't have to put the 10 there. I know some of you like to put the 10 there. That's fine, just so that way you know what's going on. That's fine. Some things to remember about log. Log b to the first is equal to 0. So anytime you have log b or log to any number of 1, then your answer is always going to be 0. If this number right here is 1, then your answer is always going to be 0. Okay? The next thing to remember is if these two are the same, if those two are the same, then it's always going to equal 1. All right? Then if you have a power, or these two are the same, and it's raised to a number, then your answer is always going to be the number it's raised to. All right? Now, if you're looking at natural logs, it's the same thing, because this right here would actually be log base E of 1. So remember, whenever you have that 1 right there, it's going to be 0. This one is going to be log base E of E. So these two are the same. It's just that this natural log, this LN, replaces this log base E. All right? It's the same thing. It's the same thing all the way through. Just know the difference between the two. They just look different because we have a common log, we have a natural log. So just know. All right. So these are rules to remember. We're going to take our time. We're going to look at a couple of them today. And then you're going to have videos with each of them separately. I think 30 different videos total. But if you are given on this side, then we have to do whatever this side tells us. So the two that we're going to look at today are these two. We will have a log on one side. So, for instance, log 3 to the x is equal to 2. Okay, that's what that one looks like. Now, for the other, and then whenever we do this one, we're going to take and rewrite it in exponential form, which is practice, left, right, left. Some of you like left, right, left, LRL. Some of you like that number thing that we do, 1, 2, 3, or 1, 3, 2. Then you're just going to write it in that order. 3 squared is equal to, that should be x, sorry. 3 squared is equal to x, and then you can solve it, because that you could put in your calculator. All right, the other one we're going to look at is when you have a log on each side. So I could have log base 3 of x is equal to log base 3 of 5. Well, when I have the same log base on both sides, it has to be the same. These two right here have to be the same. then I can drop that. It just cancels each other out. And then you have your answer and you can solve it. So that's the two methods that we're going to look at today and that we're going to practice. So the first one, when we have one log on each side, we're going to drop the logs and solve for x. So we have a log on this side and we have a log on this side. Now, they have to have the same log base. And when there's not a number there, our base is 10, okay? So this is just going to cancel each other out. And we're going to be left with 3x is equal to x minus 4. Now, you can take that out of parentheses because you're not having to worry about keeping everything together now. It's still together. It's just that the reason it was in parentheses up here is to let you know that this log base, or this log right here, went with this whole thing. That's why it was like that. So now let's go ahead and solve out for x. This is just, we've been doing this before. This should come natural to you. So subtract x, we're combining our like terms, so we have to move x. That's going to give us 2x. Bring down the equal sign. X minus x is 0. It's equal to negative 4. Okay? Now we need to divide by 2 on both sides. Whatever we do to one side, we have to do to the other. So 2 divided by 2 is x. So we're left with x. And then negative 4 divided by 2 is negative 2. So we have just solved that log equation. Our answer is negative 2. All right, let's do the next one. Same log base. Let's see, we have one log on one side, one log on the other. Same log base, so we can cancel those out. We're going to be left with 5x minus 1 is equal to x plus 7. Now we need to combine like terms. So subtract x from both sides. Now if you want to do this all in one step, you can. I'm just breaking this down into individual steps. So that way, if you need to see it done that way, you can. But 5x minus x is 4x. Minus 1, we need to bring this on down. And it's equal to x minus x cancels out. And then we bring that 7 down. All right. So now x is still not by itself. So we need to move that 1 because we want to get x on one side by itself. So we're going to add 1 to both sides because we're doing the opposite of what we were doing. Or what's going on. We're having to perform the opposite operation. So bring the 4x down. Negative 1 plus 1 gives us 0. And 7 plus 1 is 8. All right, so we have x on one side and we have a term on the other. So I'm going to move this up here and I'm going to finish my work. So 4x is equal to 8. Now my last step to solve out for x is divide by 4. So 4 divided by 4 is 1, and it cancels out. It leaves me with x. 8 divided by 4 is 2. All right. Now, there's those two. So we've just solved both of those. Okay? Now I'm going to extend my page just so that way I have room to finish this last one. All right. So I'm looking. Have a log here, log here. All right. Same log base of 10, so I can cancel them out. That's going to leave me with n plus 9 is equal to 4n. All right, I need to get the n's together, and any numbers that are standing alone together as well. Well, the only thing I need to combine is the n and the 4n. So I'm going to move it over to the side of 4n. N minus n is 0. It leaves us with nothing. We bring that 9 down, and then it's equal to 4n minus n is 3n. All right, now the last thing we need to do is divide by 3. So 3 divided by 3 is going to cancel, and then we're left with n on that side. 9 divided by 3 is 3. And that's our answer for that one. All right, so it's just the basic operations of what we've been doing, or that we've done in the past with the other units. So it should be coming quite clear to you now. All right, next page. All right, so we're looking to see if we have the same log base on both sides. And we do. We have a log base of 10. Remember, the number's not there. It's a log base of 10. So that can cancel out. We're left with A is equal to 4A minus 9. All right, I want to get those A's together. So I'm going to take, and I'm going to subtract the 4A just because the 9's over here, and I don't want to have to do anything with that 9 and keep moving stuff back and forth. Okay, so A minus 4A is negative 3A. All right, 4A minus 4A, it cancels out. We're left with negative 9. Now, we need to divide by negative 3. Remember, you divide by the number that is next to the variable, but you also take the sign with it. And this one's a negative, so we have to take that negative. All right, so negative 3 divided by negative 3 cancels. Leaves us with A. Negative 9 divided by negative 3, negative 3. Sorry, positive 3, because the negatives cancel. So positive 3. All right, the next one, number 5. First thing we're looking at, see if those log bases match. And they do, so we're going to cancel them out. We're left with negative 5x on this side, and then 10 minus 3x on the right side. Now I want to get those x's together, so I'm going to add 3x to both sides. So negative 5x plus 3x is negative 2x. And then I'm going to bring that 10 down. Negative 3 plus 3 cancels. And I'm left with negative 2x is equal to 10. So then divide by negative 2. That's going to leave me with x is equal to negative 5. All right, one more. I'm going to extend my page a little bit so that way I have a little bit more room. All right, so looking to see if those log bases are the same, and they are. So we're going to cancel that out. We're left with m squared plus 73 is equal to 17m plus 3. All right, the first thing you should notice here is that we have an m squared. Now, when we dealt with m squareds and we were solving, or x squareds or whatever squareds, whenever we were solving, if that square didn't cancel, we needed to get everything to one side, and we're going to have to factor. So, I'm going to subtract 17m from both sides. There's nothing to combine the 17m with, so I'm just going to put it in. And it should go in the middle because you always want it m squared, and then m, and then your constant. You want it in standard form. So m squared minus 17m plus 73. That's equal to 3, because 17 minus 17 cancel out. Now I want to get that 3 over here as well. So I'm going to subtract 3. Well, I know 3 can be subtracted from 73 because they're both constants. So I'm going to have, and I'm just going to put my answer right here. I'm going to have m squared minus 17m, and then we have 73 minus 3, so that's going to leave us with plus 70. All right, so that's going to equal 0. So now we can go ahead and solve. The thing is, we have to factor. Well, when we're factoring, we need to use the x method. So we're going to multiply to get 70. So multiply to get 70. We're going to add to get the middle one. So add to get a negative 17. Okay? So our factors is 70. 1 and 70, 2, 35. 3 does not go into it. 4 does not go into it. 5 goes into 70. 5 and 14. 5 and 14. 6 doesn't. 7 and 10. Now, if I'm looking at these, that's all the factors of it. If I'm looking at these, which set can I add or subtract together to give me negative 17? And it's going to be the 7 and the 10. So I'm going to have 7, and I'm going to have 10. Well, if I add those two together, I'm going to get a positive 17 because they're both positive. Well, I have a negative right here. So I need something to be negative. Well, if I make the 7 negative, 10 minus 7 is 3. So I can't do that because that's making it smaller. If I do the 10 negative and leave the 7 positive, that's going to give me a negative 3. But I have one more option. I can make them both positive or negative. If I do negative 7 plus a negative 10, that's going to give me a negative 17. So my factors are going to be m minus 7 and m minus 10. Now, I'm not finished because we're solving. That's just my factors. So what I want to do is I want to take and set both of these equal to 0. So m minus 7 is equal to 0. M minus 10 is equal to 0. Then I'm going to solve out for m. So add 7. M, that cancels. 0 plus 7 is 7. All right, so one of my solutions is m is equal to 7. All right, the other one I'm going to add 10 to both sides. All right, so bring down my m. This cancels out. So equals 0 plus 10 is 10. So my other solution is m is equal to 10. So that is how we work with a log on each side. Now let's do a log on one side only. If you think back to the very beginning of this video, we said that we would do two different ways. Well, this is the second way. So only one log present. As you can see, we only have a log on this side. There's not one. This one's missing its log. This side is missing the log. All right, so we're going to rewrite it as an exponent. We got to remember the left, right, left. Okay? Then we're going to solve. But before we do that, the only thing that goes with the log is what is after the log. So the only thing that goes with this log right here is this 2x. So we need to get rid of this right here. Well, it is sitting right next to it. So anytime you have a number sitting next to a variable or next to something else, it's being multiplied together. So we have to do the opposite to get rid of it. So I'm going to erase this right here. So in order to get rid of the 5, we're going to divide by 5 first. All right. So 5 divided by 5 is going to cancel. That's going to leave us with a log 2x. 40 divided by 5 is 8. Now we need to do left, right, left. See if you can recall what our base is. Pause it a second if you need to go back and look, or go ahead and say what it is. But there's not a log there. It's called a common log, which is a log base of 10. So we have the imaginary 10 right there. Okay? We're going to do left, right, left. Or for those that like the numbers, 1, 3, and 2. So we have 10 to the 8th is equal to 2x. Okay, now we have something we can solve. Now if I put 10 to the 8th in the calculator, I'm going to get, let me fix this. I'm going to get 100 million. And it's going to equal 2x. Now, to solve out for x, I need to divide by 2. That's going to cancel. And then I'm going to be left with x is equal to, and of course 100 million divided by 2 is 50 million. And that's my answer. All right. So when we're doing a log on both sides, we can just make sure the logs match and then cancel them out. But when we are doing a log on one side, we've got to rewrite it. First, we've got to make sure that log's by itself. All right, so if we look at this one, there's something in front of it, so we've got to get rid of it first. So it's being multiplied, so we're going to divide. That's going to leave us with log base 5 of 3x plus 1 is equal to 4 divided by 2 is 2. Now we can do left, right, left, or 1, 3, 2, whichever way you like to do it. So we have 5 squared is equal to 3x plus 1. Now we can go ahead and solve this out. 5 squared is 25. It's equal to 3x plus 1. Now we need to solve out for x. So here we go, combining like terms. So subtract 1 from both sides. 25 minus 1, 24 is equal to 3x. Then I'm going to take and divide by 3. This should be common to you because we've just done it. So the 3's cancel. We're left with x. And then 24 divided by 3 is going to be 8. All right. So pretty much just make sure that the log is by itself. If not, get it by itself on one side and then do left, right, left, what we've practiced before. All right. So we're going to take and we're going to divide by -2. So divide by -2 because that -2 is out front. And we're going to be left with log base 8 of a plus 1. And that's going to be equal to -8 divided by -2 is 4. All right. Now we can do left, right, left. Or 1, 3, 2. Again, whichever way you like. But we have 8 to the 4th is equal to a plus 1. All right. So when I put a to the 4th in my calculator, I'm going to get 4,096. And it's going to equal a plus 1. Now I need to solve out for a. So I'm going to subtract 1 from each side. So I get 4,095, and that is equal to a, because 1 minus 1 gives us 0. So my answer is 4,095. All right. Number 4. All right, this one's not being multiplied, it's being added. We have this. So we don't want to divide because it's not that operation. Well, we see that the 8 is negative. So in order to make it a 0 here, to make this 8 disappear, we're going to have to add 8 to it because it's a minus 8. So we're going to add 8 to both sides. Plus 8. All right, so that's going to cause -8 plus 8 cancels. That leaves me with log base 9 of m plus 1 is equal to -8 plus 8, and that is 0. All right. Left, right, left, or 1, 3, 2. Left, right, left, 1, 3, 2. So we have 9 to the 0 is equal to m plus 1. All right. 9 to anything raised to the 0 power, remember, is 1. So we're going to be left with 1 is equal to m plus 1. So we need to solve out for m, so minus 1 on both sides. That gives me a 0. And then m, and then that cancels out as well. So m is 0. All right. So I'm going to extend my page to make it a little bit more, give me a little bit more room to be able to do the work for this last one. So number 5. All right. We have something out front. We need to get rid of it. So we're going to divide by 7. That's going to leave me with log base 9 of x plus 8 is equal to 7 divided by 7 is 1. Now I've got 1, 3, 2, or left, right, left. All right, so 9 to the first is equal to x plus 8. Now anything raised to the first is itself. So we have, and I'm going to bring my work up here for you to be able to see. We have 9 to the first is 9, and it's equal to x plus 8. All right, get that x by itself, so we're going to subtract 8 from both sides. 9 minus 8 is 1. Bring down that x. 8 minus 8, it cancels out. So my answer is 1. All right, so that is taking and solving logarithmic equations with a log on both sides. And just remember, it has to have the same log base. If it has a log on both sides, you're going to take, and one log on both sides, you're going to take and cross them logs out if they match, and then set them equal to each other and solve. If you have a log on one side, you need to make sure that log's by itself on that one side, and then do left, right, left. Change it to exponential form and then solve it. All right. If you have any questions, feel free to ask for more practice or ask for more help to help you get it to help you understand it better. Or go back and watch the video as many times as you need to.